Good morning to all. Today our class starting with characteristic function or indicator function. So a set is defined by a function usually called as characteristic function or indicator function. A set is defined by a function usually called as characteristic function or indicator function, and it is denoted by xa of x. So that is a set is defined in the characteristic function. That characteristic function is xa of x equal to 1 for x belongs to a, 0 for x does not belongs to a. Okay, so the characteristic function is defined as xa of x. Here we get two values only, that is 1 and 0. So x to 0 and 1. For each x belongs to x, when xa of x equal to 1, x is an element of a. When xa of x equal to 0, x is not an element of a. Okay, so these 0 and 1 are known as membership function, is mapping denoted for set a. Okay, member function is a mapping for the set a. Okay, the characteristic function xa of x equal to 1 and 0 for x belongs to a, x does not belongs to a. The set having two elements, the two elements are 0 and 1. Okay, next we define the definition family of sets. A set whose elements are sets, a set whose elements are set, it can be defined in the form ai for I belongs to I. Here small I is called the index and capital I is called the index set. Okay, family of set means ai such that I belongs to I. Here small I is called the set index and the capital I is the index set. The family of set is also called the index set. For example, a equal to a1 a2 up to so on an. Next we define operations on classical sets. Okay, first definition is union. The union of set a and b, the union of sets A and B is set containing all the elements belongs to set A or set B or both A and B. It is denoted by A union B and is defined by A union B equal to X such that X belongs to A or X belongs to B. Okay, so the union of sets A and B is the set containing all the elements belongs to set A or set B or both A and B. It is denoted by A union B and is defined by A union B equal to X such that X belongs to A or X belongs to B. The generalized union operation for a family of sets, that is union of I belongs to I equal to X such that X belongs to AI for some I belongs to I. Next definition is intersection. The intersection of sets A and B is the set containing all the elements belonging to both set A and set B. It is denoted by A intersection B. Intersection means the elements containing both two sets A and B. That is A intersection B equal to X such that X belongs to A and X belongs to B. The generalized intersection operation for a family of sets is intersection of I belongs to AI equal to X such that X belongs to AI for all I belongs to the set I index set capital I. Next definition is, this is the intersection Venn diagram. The next definition is complement. The complement of set A is denoted by A complement or A bar. It is defined as collection of all elements in the universe that do not preside in the set A, that is A complement equal to X such that X belongs to A and X does not belongs to A. Complement means X belongs to A and X does not belongs to A. Okay, the element X is belongs to the whole set X and it is does not belongs to the set A. That is definition of complement. Next one is relative complement. The relative complement of set A with respect to set B is denoted by B minus A and is defined by B minus A equal to X such that X belongs to B and X does not belongs to A. So that is B by A. Relative complement means the relative complement of set A with respect to B. Set A with respect to B, it is denoted by b minus a, that is defined as b minus a equal to x such that x belongs to b and x does not belongs to a. It is also denoted by b by a. B minus a means the element belongs to b and does not belongs to a. Okay, this definition also defined as a minus b. A minus b means x such that x belongs to a and x does not belongs to b, and it is denoted by a by b. The next definition is difference. The difference of A and B is defined by the difference of A and B. So First we define a b minus a or a minus b. This is defined as a minus b means the element belongs to a and does not belongs to b. This is the Venn diagram of a minus b. Okay, that's all. Next one, the difference of a and b is denoted by a minus b and is defined as a minus b equal to x such that x belongs to a and x does not belongs to b. That means a intersection b complement. The difference of a and b is denoted by a minus b and is defined by a minus b equal to x such that x belongs to a and x does not belongs to b. It is a intersection b complement. Similarly, b minus a equal to x such that x belongs to b and x does not belongs to a. That means b intersection a complement that equal to a complement intersection b. Okay, a intersection b complement or a bar intersection b. Next definition is symmetric. Symmetric difference. The symmetric difference of A and B is denoted by A delta B. The symmetric difference of A and B is denoted by A delta B and is denoted by A delta B equal to A minus B union B minus A. A minus B union B minus A. And notations. Here also we know the some notations. Here these definitions are union, intersection, complement, relative complement, difference and symmetric difference. Definitions are completed. Okay, next note. If the set B is the universal set, then B minus A equal to A complement. If the set B is the universal set, then we denote that B minus A equal to A complement. Next one is A complement whole complement equal to A. A complement whole complement equal to A. And next one is pi complement equal to U equal to X. And another one is U complement equal to X complement equal to pi. Okay, next we define the joint operator or maximum operator. This is joint operator. Meet, this is the minimum operator. This is also known as meet. This is joint. Maximum operator means joint operator. Meet operations means minimum operator. Okay, next the union, intersection, composition, containments of two sets, the function heuristic terms is given as follows. Like we define the union operator. We define the union for two functions a and b is defined as a union b tends to x of a union b of x equal to xa of x or xb of x. Xa of x or xb of x equal to maximum of xa of x comma xb of x. Okay, the operator union is defined as A union B tends to X, A union B of X equal to XA of X or XB of X. That is maximum of XA of X, XB of X. Next one is next operator is intersection. That is A intersection B tends to X, A intersection B of X equal to XA of X meet XB of X. XA of X meet XB of X. That is minimum of xa of x, xb of x. Next one is complement. A complement tends to x a bar of x equal to 1 minus xa of x. X bar tends to x a bar of x equal to 1 minus xa of x. Containment is a is contained in b. Xa of x is less than or equal to xb of x. Xa of x is less than or equal to xb of x. Union, intersection, complement, containment. Okay, a union b is x a union b of x. That is xa of x, xa of x join xb of x. That is maximum of xa of x, xb of x. Intersection a intersection b tends to x a intersection b of x equal to xa of x meet xb of x equal to minimum of xa of x, xb of x. And another next one is complement. That is a complement equal to x a bar of x equal to 1 minus xa of x. And another one is containment. A is contained in b, that means xa of x is less than or equal to xb of x. Okay, next we go the fundamental properties of classical sets. Fundamental properties of classical sets. So the most fundamental properties of set operation of absolute complement, union, intersection are summarized in the following table, where a b and c are assumed to be elements of the power set P of x or xa of x. Assumed to power set P of x or xa of x. So The first property is involution. The first property is involution. A complement whole complement equal to A. A complement whole complement equal to A. Commutative, that is A union B equal to B union A. A intersection B equal to B intersection A. So involution means A complement whole complement equal to A. Commutative is A union B equal to B union A, and A intersection B equal to B intersection A. And then another one is associative, that is A union B union C equal to A union B union C. A union B union C equal to A union B union C. And another one is A intersection B intersection C equal to A intersection B intersection C. This is the associative. And then last one is distributive. So distributive means A union B intersection C equal to A union B intersection A union C. Distribution is A union B intersection C equal to A union B intersection A union C, and A intersection B union C equal to A intersection B union A intersection C. This is the distributive. Next one is idempotence. Idempotence means A union A equal to A intersection A equal to A, and absorption is A union A intersection B equal to A intersection A union B equal to A. Next, absorption by x and pi is here A and B, here x and A union x and pi is A union x equal to x, A intersection pi equal to pi. Next, identity is A union pi equal to A union pi equal to A intersection x equal to A. So, law of contradiction or axiom of contradiction, A intersection A complement equal to pi, A intersection A complement equal to pi. Law of excluded middle means A union A complement equal to x, A union A complement equal to x, and De Morgan laws. These are A intersection B whole complement equal to A complement union B complement. A intersection B whole complement equal to A complement intersection B complement. A union B whole complement equal to A complement intersection B complement. These are the properties of the crisp sets. Okay, ma? Thank you.